Welcome, everybody. We are going to be working on Module 7 tonight, and our topics will be as follows. So we're going to look at inheritance first, and then we'll look at overriding. We'll look at the two-string method. We'll learn about what static is, what aggregation is, and then abstracts and interfaces as well. And these are all, I would call, higher level topics related to objects and classes, but very important knowledge for coding in C#, which uses most of these tools very regularly. How far we'll get tonight really is kind of dependent. I'm going to kind of go by feel, but I do have the expectation that I'm going to at least split the content delivery into at least 2 nights, and maybe into 3, with the third night, so the Tuesday of next week is probably when we'll start doing the labs and the assignments. And I'll make sure that the due dates are adjusted accordingly. And with any luck, maybe we'll end early tonight. I know I say that every week, but we'll see. Right? I'm not going to be overly ambitious. I do, like I said before, I do want you guys to get your money's worth and learn the stuff you're supposed to learn. All right, so we're going to start with this concept of inheritance, which is a really important concept with objects and classes. And it might not immediately resonate. So I say that I feel like I'm saying this often now. But once you've done this a few times and you see kind of what we're talking about, it makes more sense when you talk about it conceptually, rather than like if you were to read about it and you go, I don't get it, right? But when you see it in action, it makes a whole lot more sense. All right, so let's start with this concept of generalization and specialization. And it says here, in the real world, there are general and specific things. So for example, there's grasshoppers and bees. Both are very specific types of insects. And you can take any other insect that you could think of and lump them into the same category. So for example, a fly is an insect too. An ant is an insect. Question, is a spider an insect? Do you know what the qualifications for an insect are, anybody? Right. One of the qualification is that they have an exoskeleton and that they have 6 legs. How many legs do spiders have? So therefore, spiders are not technically insects. They're actually arachnids, right? But grasshoppers and bees absolutely are insects, and they're very specific types of insects, right? And so they share some properties that are the same. So the one would be 6 legs, the 3 body segments, and I forget what it is, like abdomen, thorax, and head or something like that, and then an exoskeleton, right? So regardless of if you're a grasshopper, a bee, a fly, an ant, or whatever, you have all of those things because all insects have those things. However, grasshoppers and bees are unique. I mean, they look different. They're different sizes and shapes, sort of. But they have their own special properties. For example, grasshoppers can jump, but bees can sting. And I wish I'd, probably used a better thing there, because then it makes you think that all bees do is sting. And I will tell you, because my wife and I have been beekeepers in the past. We're not doing it currently, but we used to keep a bunch of hives. And they really only sting you when they're freaking out. But they also pollinate. That could be a property where grasshoppers probably don't do that process. So in terms of like terminology and the way to think about it, we talk about the is a relationship approach, right? So it says inheritance creates an is a relationship. So for example, a grasshopper is an insect, and a rectangle is a shape, and a customer is a person. And so really what we're talking about is the item on the right here is basically the general, item, and then the specific one is on the left. So a customer is a specific type of person, and a rectangle is a specific type of shape, and a grasshopper is a very specific type of insect, right? So there is a relationship between those. And this is kind of the root of inheritance. So when we learn about inheritance, we have like what we call our class files where we're creating that blueprint to create an object in memory. And then we kind of learned a little bit kind of indirectly, and I don't know if you guys are realizing this, when we did the recipe thing last week, we weren't exactly, following this approach, but sort of. And it was kind of like gently introducing the information to you guys is what I was doing. But when we think about the general thing, we think of that as what we call the superclass. So the insect would be the superclass to the bee and the grasshopper. The other terminology that we use in C# is we call it a base class. Right? Most other languages we call it a superclass. And you know what? There's this weird, way of looking at it as well, where you can think of it as a parent-child relationship in a way. So the insect class is the parent, and then the grasshopper would be the child, right? Or the insect is the superclass, and the grasshopper is the subclass, or the the insect is the base class, right? In C#, they tend to like the terminology of superclass and base class, right? This terminology does extend to other languages, and we tend to use the same term. So when you switch to a different language, for example, if you learn Java or Python or whatnot, it doesn't really matter, you will see this sort of thing happening in those languages. So any language, by the way, that has the ability to create objects and classes has this capability to inherit. So, think about this. It says, the insect class is a superclass. It contains things that are common to all insects, right? For simplicity, we could just use name and color. So that's kind of the suggestion. So if we, so all insects will have a name, and all insects will have some sort of color. I don't know if I like those as, things, but it is what it is, right? That's the example that's given. Now, if we kind of look at this from a hierarchical standpoint, in other words, how the insect, sits relative as a superclass relative to the subclasses, we think of it kind of like this. So bee and grasshopper are the specific subclasses, but they inherit the features of insect that are common to all insects. And what was that again? 6 legs, exoskeleton, and the 3 body parts, right? And according to the previous slide, name and color, so all the insects have some sort of a name. That makes sense. All of them have some sort of color, I guess, right? All right, so the specific things are subclasses. The alternate terminology is a derived class. So the bee class is derived from the insect class, is another way to look at it. That is not terminology I normally use, but I usually call sub and super, parent, child, that kind of thing. All right, so I think that we covered all that info pretty well. Now, it does mention here, it says subclasses inherit from their superclass. All right, so because there is a superclass, we will grab those features from that superclass, and it will be part of our object automatically. Kind of the same way the ingredient list was part of the recipe. Hopefully you're kind of seeing that connection now, right? So the recipe one was actually a really good example from the standpoint of like, what makes up a recipe? Well, a recipe kind of has a few things, right? It's got a title, it's got a list of ingredients, and it has instructions. We never got to the instruction part, but you could, derive from that very easily. And then when we, we're basically taking the one type of class and putting it inside the other, it wasn't exactly what we're doing here, but not too far off. But introducing to this concept that you can get multiple classes working together to create a solution to something. All right. Now, the other aspect of this, so we move away now from the general to the specialization. And it says subclasses contain their own fields and methods to make them specialized. Okay, so once again, back to the original example, a bee is different from a grasshopper, right? in that bees have a stinger and grasshoppers don't, right? Um, you might say to yourself, well, bees have wings and grasshoppers don't. No, well, grasshoppers have wings too. And then you say, well, you know what? Actually, that's a property of insects that I don't think that they're really thinking about here. But all insects have wings, by the way. Yeah, even ants have wings. Not always, right? Only they have like one special time of year where they sprout wings and they fly around and they mate with the queen or something like that and propagate the species. Um, but it's short lived, but they do have them. And I think it's kind of a fascinating thought when you start to break it down like that. Um, but the specialization is important. So, like, what makes the bee different from the grasshopper, but still an insect? And so that will be unique to every insect, right? Every insect will have certain features, whether it's a size thing or the color or what capabilities they have, right? The bees can sting, but they can also pollinate. I don't know if grasshoppers do that. There's other insects that pollinate too, but not all insects pollinate. Right? All right, let's move on. So when we get to the point of trying to implement this stuff, we're going to look at some code conceptually here, and then we'll start to try to build some of it. All right, so it says here, to say that grasshopper and bee inherit from insect, we use this terminology. So notice the text in blue, right? So if I'm creating a grasshopper class and it inherits from the insect superclass, or it's derived from the insect superclass, we use a colon and then the name of the class that we're inheriting from. So whenever you see a class being defined, it's followed by a colon and a name. That means this is your superclass. The colon implies inherits, and then this is the current thing. So whatever capabilities are built into insect are now also part of grasshopper, right? 6 legs, exoskeleton, 3 body parts, wings, a name, a color, whatever. The same thing happens with bee. They're also inheriting their base properties from insect. So insect is the superclass, bee is the subclass. Right? We are inheriting or deriving all the aspects of insect when we generate a bee. Now, when it comes to actually getting this to go, right? So, it says nothing special needs to be done to insect to make it a superclass. It just is what it is. So in this case, we're using the really simplistic name and color, right? So an insect will have a name and color. We can set those to get and set. So you can easily adjust those values. Notice they're set to public in this example. And from the standpoint of the superclass, insect has no clue that there's a thing called grasshopper, right? But the grasshopper is an insect and it will inherit both of these properties or data fields, if you will, into its structure automatically. So when we inherit and we create the grasshopper class, it will have a name and a color because we're inheriting that from the insect class. And what that allows us to do is not have to include that information in the grasshopper class because it comes from the superclass. Let's move on. All right. Now, the weird thing is, if we do have other fields that are privates, and we're trying to do a conception thing here, because if you think about this, with an insect, it would make sense to have name and color be public fields that can be get and set, because that way we can apply it to any insect. So if I have a grasshopper, I can assign the name grasshopper and then say green, or whatever color the grasshopper is. However, the private field of how many legs it has, that's not really changeable, right? It's private, and grasshopper can't go in there and change it. We don't have a get and a set on it. And you know what? Because it's a given, all insects must have 6 legs. And we could also have, exoskeleton equals true. I'm just kind of putting, some stuff out there to have you think about, or abdomen, thorax, and whatever. Uh, head and antennae. I don't know what the third body part is. I'm sorry, I don't remember my biology too well. But it can't be changed from Grasshopper, and it can't be accessed from Grasshopper because it is private, and it really has no need to change it because that's just a given for a Grasshopper. You see the logic there, right? So the conception is Grasshopper has 6 legs. We can't change this. It just is what it is. It will travel with the object. So when we inherit Grasshopper from insect, it comes with 6 legs, right? But I can give it a name and I can declare what color it is. So what if you need to access these private data fields? You could, for example, take a look at what they're doing here. So we have our color name get set, to count legs at 6, and then we have basically a private method here where we're talking about lose a leg. So the count legs minus meaning, okay, well, that one got pinched off by a beetle or something, or somebody grabbed the leg and pulled it off, right? So it's possible that an insect could lose a leg, but once again, that's private. So, all right, let's see what it says. It says private fields and methods aren't visible in the subclass. So when I'm in Grasshopper, I can't see this and I can't see that, right? And I can't access them. They exist in memory, not directly accessible, right? Because they're marked private. I mean, that's the whole point of private, is that they're not accessible. So if you're in the B class or the Grasshopper class, I can't run the method from the super class called lose leg and then try to do an output to count the legs and see if I'm down to 5. It won't work because the B class doesn't have access to the super class private data field or the method to trigger it, right? Only the super class has that capability, right? If they were switched to public, well, then they would be accessible. Interesting, right? But in some cases, you really don't want to make stuff that way because it's not always really good practice in programming. The other kind of interesting aspect is, as far as constructors go, the constructors are not inherited. So if the superclass has a constructor, that constructor does not travel down to the subclass. The subclass will have its own constructor. Now keep in mind, right? If I'm going to construct a Grasshopper or a bee, it's automatically going to grab all the capabilities of insect with it, right? The public ones, right? The other ones are built into the object, but I can't really do anything with them. Okay, so it says constructors are not inherited. Their job is to create, initialize an object. An insect constructor creates an insect object. Why would Grasshopper want to only be an insect? You see kind of the logic here? So if I was creating a Grasshopper, I wouldn't want to construct just an insect. An insect is, or Grasshopper is an insect already. So I don't need to construct the superclass. I know that's kind of a fuzzy one a little bit, probably, right? All right. So then we kind of move on from that and we say, how do constructors work in inheritance then? Right? It says the superclass's constructor always executes first before the subclass's constructor. So in other words, if we were, this is a really good example, I think. So take a look at this one. If I have a class called pet, that's a generic, right? That's the superclass. And then pet has its own constructor. We're not worried about the data fields here. We're just looking at constructors. So if I was to construct a pet, right, the constructor function, what is it done? Is it just says constructing pet, right? But if I'm going to construct a dog, so I have a class of dog, and then it's going to inherit from pet, and its constructor also just does a write line that says constructing dog. When I move on to actually propagate this code, here's the interesting thing that happens. So if I say dog Fido equals new dog, We call the constructor in dog. So just go back here for a second. It does the right line, constructing dog. But before it does that, because it's inheriting from pet, it jumps over here, does this first. It automatically grabs the superclass constructor and executes it because it is inheriting it. So when we do the constructor, it first constructs the pet and then constructs the dog. And so the output for that would be this. It would be constructing pet, constructing dog in that order. The inheritance happens first, and then the specialization. So the general happens first, and then the specialized happens second. See how that works? Kind of interesting, right? So when we construct a dog, because it is a subclass of pet, it will automatically create a pet and then the dog with the other specifics. Of course, we're not looking at any of the data fields or any of the other functions or anything like that. We're just looking at constructors right now. But the point is, when you create a subclass, it grabs all the superclass stuff with it automatically. So therefore, I don't need to construct twice. I don't have to construct a pet and then construct a dog and then somehow put the dog inside the pet. You know, it just is, your dog is a pet, you know. And if you think about it like that, it makes a whole lot of sense. Kind of like a customer is a person and a rectangle is a shape, right? Or a bee is an insect, a dog is a pet. Maybe a domesticated animal is better, right? Family member, you know, for most of us, right? You know, as my dog sits here like inches away from me, she, whenever, you know, by the way, I'm doing these Zoom sessions, she's usually curled up at my feet or, you know, right by my side. She just always has to be there. You know, that's just her personality. Uh, and we love her for it, right? You know, okay. So let's talk now about multiple inheritances. And this is kind of another really important concept here. A bee cannot inherit two superclasses. C# does not allow this. In fact, I can't think of any programming language that does when I think about it. So a bee cannot have two superclasses. It can't be both an insect and an animal because really both are true, right? And if you want to think about it on a higher level, a bee could inherit from insect and the insect could inherit from animal because an insect is a type of animal, right? And so we could expand the tree up, but we can't spread out is kind of the point. However, we can grow the tree downward, as it says. So the insect, I mean, how many insects are there? Gosh, I don't even know. Probably a million different types, you know, at least thousands, right? And that can expand. So this part of the tree going downwards can expand as far as you need it to. But all of them, if they're inheriting from insect, can only inherit from insect. Now, all right, so here's kind of the thing I was talking about below. So we can't do the thing on the left. I can't inherit from both insect and animal separately or have any sort of statement to do that. But B can inherit from insect, which can inherit from animal. I'm not sure what property animals have, you know, that would make them universal. Maybe name and color again, you know. But I mean, what is an animal? I mean, do humans fit under that category? You could certainly make that argument, right? You know, we certainly have a lot of the same, you know, characteristics, in many cases, behaviors. You know, we like to think that we behave better than animals, but sometimes we really don't. You know? But you should aspire to, you know, if you want a little philosophical lesson, try to be the best person you can be, folks. Right? Makes the world a better place. You know, to be really cheesy about it. But yes, we can inherit in that regard. And you know what? We could even go, you know, farther up the tree. We could have an animal inherit from, I don't know, um, you know, beings of planet Earth, you know, for example, which inherits from beings of the universe or something, you know. So you could kind of go up the line if you wish, but you cannot do it upwards and outwards, just straight up or straight down. The thing that we're also not talking about here is that, you know, in principle, think about the fact that we have grasshoppers, but maybe there's more than one kind of grasshopper. In fact, I'm pretty sure there are, right? There's probably like the grasshoppers we have here in Wisconsin might be different than the grasshoppers you have over in Asia or Africa or South America or something. So grasshopper could become a superclass for all the other types of grasshoppers. That's possible, right? So um, that's not really shown here on the diagram, but it can go the other direction too. So it says inheritance doesn't work in reverse. It is a one-way relationship. And that's why all the arrows in the diagram point upwards. Because what are we in the representation is, what are we inheriting from? We're inheriting from the superclass. Very much in the same way, and why I like to use sometimes the parent-child relationship, because I think it resonates a lot. So any of you that might be parents, or have siblings or families, which all of us do pretty much, um, think about how remarkable it is that children inherit certain aspects of their parents, whether it's their appearance or their behavior or their hair color or their body stature or whatever. It's a very amazing thing. So like, for example, if you were to look at my children, you would not doubt for a second that they were my children, because you could tell they look very much like me. I guess that's good, right? And at least I know they're my children. um, but that's kind of an interesting thought, right? So like, what is it that they're inheriting from me as the parent or the superclass, and as the child or the subclass? What are they deriving from me? I mean, they're grabbing certain parts of my DNA, and you can think of that DNA as both the data fields and the capabilities that might travel in that inheritance relationship, right? So, but it doesn't work in reverse. I'm not going to be inheriting anything from my children because they're not creating me, if you will. So that's why I like the parent-child thought, because that makes it a lot more clear. My children cannot be my parent. You know what I mean? You can only inherit from your parent. So it is not a two-way relationship. It's only a one-way relationship. I'm sharing DNA with them. They're not sharing DNA with me. Um, and as it says here, superclasses get nothing from their subclasses. They can't call their methods, and they can't use their fields, right? So the insect cannot grab anything from the grasshopper or anything from the bee. It can only provide stuff to them, but it can't get stuff from them. Okay, so hopefully that drive home that concept pretty clear. Now, the reason I like using the parent-child terminology is because I think that is a lot more clear, because when you think of that word inheritance, it really resonates a lot better when you think about parents and children. And it's just a very, very, very clear type of relationship. So when we start to think about the superclass constructor, let's take a look at these bullets here. It says you can't choose to not call a superclass constructor. All right. So in other words, if I'm going to construct a grasshopper and it inherits from insect, the moment I construct one, well, I've also constructed an insect. See what I mean, right? So I can't choose not to be an insect if I'm creating a grasshopper. If you don't explicitly call one, C# will call the superclasses no arg constructor. All right. So in other words, when we are building any sort of a class, right? And I don't know if you guys remember this from the objects and classes lecture. It's not an obligation that a class has a constructor function built into it, right? If there isn't one specified, it will just take whatever data fields that you have and just construct those and assign default values. Null for strings, zeros for numbers, etc. Right? More complex objects, will depend. So if there is no constructor, the no arg constructor is called. Okay, so the question: what if the superclass doesn't have a no arg or default constructor? Right? Well, I think I just answered that question. And what if you want to call a constructor that has arguments? All right, so this is where it gets maybe a little weird. So we're going to introduce another piece of terminology here, right? So we use this keyword called base. And what that refers to is the object's superclass, right? So we can use that keyword basically to bring in that superclass and its methods and its constructors if our subclass is missing those things or has things that conflict with it, right? So this is where it gets kind of interesting. So let's think about the examples that they have here. So consider a person class. That has a to-arg constructor that will initialize the first name and the last name. So remember that I think the example that we're using here is a customer is a person. So customer inherits from person, right? But the superclass has a to-arg constructor where we can feed in a name, a first name, and a last name, right, to make them a person, right? And we have to agree, all persons generally have a first and a last name, sometimes a middle, or I guess you could be like Prince and have just a one word title or a symbol. You can have, I guess these days you can use an emoji for your name too, if you wish, right? And then a customer then will inherit from a person, and it says that has a 3-arg constructor that conflicts a little bit. So that the customers also have a first and last name and an account number. Okay, so what happens in this situation? So let's take a look at first person. So this is the superclass. So it has 2 data fields, first and last name. They're both set to public. They can be get and set, right? And then when we run the constructor function, so we would instantiate, we'd say like new, whoever equal, or we would say person, whoever equals new person, and then we'd feed in first and last name, John Smith, for example. And then those would be assigned to that superclass. But then when we're doing the subclass, notice kind of what happens here. You're trying to construct now the customer, which also has a first and a last name, right? And it, little funny comment there. Oh, C# wants to call a superclass constructor here, but only person has this one. All right. So, once again, having a little reference there. So now how do we kind of work around this is really the question. And this is where the base keyword comes into play. So first, let's think about this. It says a customer must call a person constructor, right? So it has to pull from the superclass. Person doesn't have a no argument constructor, like a default, where we could just make them blank, right? Or empty strings or something. So we can't call it. That creates kind of a problem. So we can't like implicitly call it from the other class. We must explicitly call person's to argument constructor, pass it the other 2 values received by the other constructor. So we're kind of going to do a handoff. We're going to allow customer to construct, feeding in first name, last name, and account number. And then we're going to hand that off via code to the superclass to actually build those fields. So it's not actually going to be handled by the subclass. It will be handled by the superclass. And the way that we do that is like this. So we'll say, we'll feed in the stuff the way that we do, and then notice the terminology here to show the inheritance. And then we're going to pass off to the base or the superclass these 2 things. That will take care of it for us. And then the only thing that we have to do in the constructor is handle the account number. The other 2 fields are handled by the superclass. They're handed off through the base keyword. Right? And of course, we're only passing 2 values right here, but it could be 5 values or 1 value or 10 values or whatever. And yes, it could be any type of data, whatever it happens to be. But I like the fact that we have this little thing here that we can refer to. So we'll still feed in and instantiate this. And then but hand off these two pieces of information off to the base or the superclass, which goes here and constructs it here. And then it's still part of the object. First name and last name travel with. They're part of the superclass. They're included in the subclass. Account number is unique. So this is a really common type of way to do this. By the way. All right, so here's what I think we should do. We have a little try it out here, but before we do the try it out, let's take a break and then we'll come back and work on this, see where we're at with it, answer any questions, and then we'll move on with the next topic. It is right now 7:56. Let's come back, let's make it a little bit longer break. So let's come back at like 8:03 or 8:04. So you guys get a chance to step away, hit the bathroom, get a beverage, etc. So see you guys in about 7-8 minutes. Recording. All right, so we're back from our break and we're going to give this try it out a shot here. And what I've been doing at this point is I've been kind of reviewing a little bit of the code and stuff that we're yet to cover yet tonight. But at the same time, I've been just kind of thinking about how I'm going to proceed in writing this, because I've already kind of have all my code written, and I do have a cheat sheet that I'm pulling from, by the way. It doesn't mean I'll do it exactly that way. And I did all the stuff for module 7 into like one program, which probably isn't really a good idea, but it's a good way to kind of conglomerate it and use it as a cheat sheet, which was kind of my goal. However, I am going to go into Visual Studio and get a new project going here. So let's go ahead and create a new project, and of course a console app. And as we've been doing of late, I'm going to be leaving the box check, but we do want to let this get named here. So we'll say module 7, try it. Try it out, I think that's what we're calling it. Are these try it outs, plural? I guess they're try it outs. All right, so I'm going to go ahead and use try it outs, whatever, just so I have a name on it. I am checking the box, and then I'm going to let it build. There's Visual Studio with my namespace in place. And then we are basically going to have a main method that is going to steer everything here. So the main method is going to run all of our stuff. And for right now, we're going to comment this out or remove it or delete it. We have very specific directives, so it's not a bad idea to just kind of look at what we need to do. It says create a rectangle class or use your existing one. It should have a length and width property. Add a toArg constructor that initializes length and width, and then create a cube class that is a subclass of rectangle, and it will have a height property, and add a 3arg constructor that initializes height, call the constructor, initialize, etc. Okay, so we're going to try to do all these tasks here. We're going to do these all together. Now, I have to think, when I'm coding this stuff, and we're starting to get to the level now where our coding is becoming a little bit more robust and, frankly, a little more real, right? And we have to think about how we're going to build these files. Now, the one thing I could do, and we've talked about this already, is I could build all the classes here inside the program, or I could create external files and have them pulled in, right? So that's entirely possible. So I think what I'm going to do, and I've really been debating this a lot, because I think about kind of this whole concept of, okay, rectangle class, and then we're going to create a subclass called a cube. And I still think of these all as shapes, right? So I'm going to actually create an external file. So over here, I'm just going to go right click, add a new item, and I'm going to create a file called shapes. All right. I'm not going to need any of these using statements. This is going to be a blueprint file, by the way. And now I'm having like second thoughts on this, right? Like, is shapes really the right thing I want to do here? Right? Because really, a shape, rectangles and cubes are shapes. Now I'm changing my mind. All right, so I'm gonna, because when I did this before, I kind of used a different approach. So actually, I'm not going to say it. I'm gonna do this again. and I am going to come over here and delete it. So if you guys haven't done this process before, you can do this. So you can create a file and delete it if you haven't done that before. So don't be afraid to do it. So now I'm thinking instead, why don't I go ahead and just directly create the, I'm trying to think of what, because before I did it all in one file, should I just do it all in one file? So you see like this debate I'm having in my head here. And I think that what's going to make a whole lot of sense to me. Now I'm thinking I'm going to do it all in one file. Although if I do my other examples, would that help my other examples? It's not going to hurt anything. So you see, I'm having this whole debate and I'm doing it on purpose during the recording and during the session because I want you to kind of see my thinking on this. So when you begin a process and you're doing something maybe a little more complicated than the code that you've been doing before, I want you to think back to the very beginning of the course. Here I am, and I'm doing the cardinal sin of coding, which is I'm jumping right into the code and I'm starting to write, and that's not really the smartest way to proceed. Sometimes it's better to take a moment and think about what we're building before we build it to make sure it builds correctly and is fully accessible to what we're doing. So I'm having all these like big debates in my head as to how I should proceed. And I'm having debates, right? Because I could proceed in a number of different ways. I think I've demonstrated both techniques where I can create the class files externally and when I can create them internally and what would be most logical here. All right, so I'm having this grand debate, and I think that what I'm going to do is I'm probably going to end up kind of doing a hodgepodge, right? Different than what I did before and different than what I've done previously. So I am going to add a new item. I'm going to be careful about how I name this one. So let's go ahead and what should I name this? Would rectangle be the correct thing? Rectangle is going to be our superclass, right? So maybe I should call it rectangle. Now it's not. Now see, I'm debating again. All right, so I'm gonna cancel that just for a second and think about it for a second. Does anybody have a predisposition here? Like, what do you think would be a good way to proceed? Like if you were to sit down and do this, what would be the first way that you would do it? Anybody have a thought? And really, I'm kind of curious as what your thought processes are. Would it make sense to do it all together? Okay, maybe. All right. So how about this? Right now, I have a class called program. Maybe I am going to do this all inside one file because I'm thinking that it might be faster to kind of create this. So let's create a public class called rectangle. And you guys don't have to do it this way, mind you. So there's my class definition. We do have some information. It should have length and width properties. All right, so we could add length and width properties. So here I am. I'm just going to copy and paste these in, by the way. You should do the laborious task of typing them in. So I'm setting both of them to public on purpose. Right? And the reason I'm doing that is so that they can be accessible. Right? All right. So that was the first directive. Let's also do this. It should have length and width properties, and we want a 2arg constructor that initializes both of them. So remember, when you're building a constructor, you're going to be inside the same class file here. So we're going to create a public rectangle. There's our constructor function. And then inside the parentheses here, we're going to feed in a double for length. And notice I'm using lowercase here to make them different. And then we're going to do a double for width. Inside the curlies, we're now going to start assigning some of these values. I'm going to switch to the C# style here, which is this. This is what Microsoft prefers for sure. And we're just going to assign those now. So we're going to say, length equals length, and width equals width. And thank you, Visual Studio, for typing my code for me. Do we have any other directives here? We just want a 2arg constructor. That for now, that's going to be enough. Okay. It says create a cube class that is a subclass of rectangle. All right, so let's do that part first. And so this is why I had this debate in my head, because now I was thinking, if I create the one class as one file and then create the other class as a separate file, which I could have done that. So I could have created a rectangle CS file and then a cube.cs file, right? And if I was writing a real program, by the way, I'd be much more apt to do it that way, right? To have them all as separate files. The reason is then I could pick up the individual files and move them to any project I want. But here we're demonstrating, and it's going to be easier to see it all if it's in the same place, basically on the same screens. I'm going to tighten up my space here a little bit. Then inside that closing curly bracket, I'm going to create the class for cube. So once again, we're going to go public class. We're going to call it cube with a capital C. And we want this to inherit from the superclass rectangle. Like so. And of course, let's get our curlies in there. And what was the other thing? It will have a height property. So let's create a height property for the cube. So I'm just going to copy paste this one in. So we're making it public, a double, and a height with a capital H with get and set capabilities. So we can adjust those fields. Next directive is, and don't worry, I'll go back. We're going to add a 3-arg constructor that initializes height, but we're going to call the rectangles constructor to initialize the length and the width. Right. So if you guys remember how to do that from the really recent example. So inside of cube, now we're going to create the constructor. So I'm going to go public cube. We need our parens. And now we got to start putting stuff inside there. I'm going to preemptively do my curly brackets to kind of let them set up. And then inside here, I'm going to go ahead and start feeding in the data fields with different names, lowercase in this case. So we're still going to do length. We're still going to do width. And then we are also going to do height. Right? All lowercase versus the uppercase ones, just to make them different. So those are the 3 things that we want to do. We were told to do that. And then we are going to inherit from the base or the superclass of those 2 properties. And notice it's suggesting width and height, but it's incorrect, right? What we really want to have in here is what? Length and width, correct? Yes. All right, so we're going to inherit length and width. So inside here, we will say length and width. And why are they in that order? Because that's the order they appear in the superclass. That's why. And I'm going to do a save on this, by the way. And see, eventually it did pick it up. I was a little surprised the IntelliSense didn't pick it up sooner. But notice as I put that in, it recognizes the superclass. The engine inside of Visual Studio automatically recognizes it. Right? So there's kind of the way that we pull those in. Now, because when we construct this, by the way, we will not need to internally set the length and the width. Those are going to go to the superclass. Inside here, we only need to assign height, right? That was the example we had. So we're going to say height equals height lowercase. That's the one thing we're feeding in. The other 2 will be delivered to the superclass, and the superclass will take care of creating those. But those will still be present inside here. All right. Now comes the fun part. So up here, we have to try this. We have to actually create some rectangles. And so let me see if I can find my code where I did that, because I have so much code in this on the screen, well, frankly. Yeah. I think next time I won't do this, because I think I created, like, for all the try it outs in here, I created, like, I don't know, like a 500 line program or something. Yeah, okay, not to freak you guys out, but yeah, there's a lot of code here. So I'm trying to find my rectangle code, basically. Are we actually asked to instantiate anything? I don't think so. All right, so we do want to call the constructor to initialize length and width, and I think that we already did that. So why don't we go ahead and construct, let's just do a really simple construction here. Now the question is, if we want to instantiate a cube, what's the terminology we start with? What's the first keyword I should use to do this? I'm going to use cube. That's my custom class. And I don't know what I'm going to name it, cube one. That sounds like a great name. Then we're going to call the new, which we'll call the constructor, and we're calling cube. And then that's expecting, and this is what I love about Visual Studio, it just pulls it in automatically. It's telling me the format of what I need to provide. And so I can hard code this stuff, right? So I can just throw numbers in. So I can say, 2.5 and 4.75 or 6 or whatever I just typed. And then a height, which is, I don't know, 11.0. And I don't know what these numbers mean, but I'm just typing them. So that constructs my object. And how would I now take a look at this stuff, inside these objects? So that becomes the second question here is, how do I know that this is even working? That's the thing. So we're going to have to do something that allows us to return some of these values, if you guys feel where I'm going with this. So, all right. So we created it. How do I look at some of these values to see that they actually worked? Right? I'm not getting any red underlines, so my code must be okay in the constructors. So if I want to look at cube one, and I want to look at a specific property, right? Well, it's showing me right now, it's trying to autofill assigning a value. I don't want to assign a value. I want to look at the value. Could I just do a console write? Yeah, you could do a console write. So let's just do that. That's one way to do it. So let's do a console write line. And then, we can just drop in cube one, I guess. But let's say if we're looking at, well, let's look at each one of these separately. So first, let's look at, let's just take them in the order they're here. So let's just look at the height. And I'm going to run this to make sure it even works. Does this work? Does it compile? And does it give me what I'm looking for? Well, 11. Is that the height? Yeah, that was the height. Right. So very similarly, I could just simply copy this line of code. So we're just making sure that it created the object correctly. And so here we could do, I think we go length, and then we can paste again and do this. And of course we can run it. And this is really primitive example, but it's just showing that the values are being transported and set. So when you look at the code here, and I'm going to try to have this all on the screen at the same time, is kind of helpful, right? So we can see the super class, and you know what, I'm going to label this, super class. Subclass, which inherits from the super rectangle. Excuse me. And then having the console back up on the screen here, and keeping in mind that when we run this constructor, we are asking for all three values, but those two are being handled by the superclass. And could I, for example, write line, could I do like rectangle.height and get a value out of it? The answer is no, because you got to keep in mind here, rectangle is a blueprint. When we create the cube, we're pulling in all of these capabilities into cube. And when I instantiate a cube, I mean, I'm building it off of this, but the cube is its own thing, which happens to have those capabilities. So I couldn't directly like output what rectangle is because rectangle is not an object, it's a blueprint, it's a class. Cube is an object that we created from the blueprints so that we can extract properties from, we can look at them, we can print them, we can set them. You know, you guys see the process of that. So this is a really simplistic example. But if we wanted, for example, we could add methods that would allow us to output the values, to calculate the area or the surface area or the volume or whatever, you know, it happens to be. We can write internal methods to handle all of those pieces. And as we go through the examples, we may do that. It just depends on what the tryouts are asking for. Did everybody get this to work okay? Right. Do you find it helpful by creating it that do you see it better in that regard? Yeah, I think so. Right. And for me, I think that helps a lot. Frankly. So let's go ahead and close the console. I'm going to save my work here, by the way. So if you haven't control S it, if so to speak, go ahead and do that. Save your code. All right, and let's move on now to this concept of overriding. So this is kind of another special feature of working with inheritance in general is, you know, we have the superclass, we have the subclass, and each of those can have its own data properties and its own methods and their own constructors, right? Now, what's kind of interesting about this, overriding is a special type of feature. So it says a subclass can have a method with the same signature or name, if you will, as the superclass. So for example, a subclass method will override a superclass method. So this is kind of an interesting thought. So for example, if you have a pet class and it includes a speak method, right, that writes hello, and then we have a dog class that inherits from it and overrides speak. So the dog class also has a speak method, but that one writes woof. So if I say dog speak, it's going to bark. You know, it's not going to say hello. You know, my parrot might say hello, but the dog is going to say woof. Right. And so that's kind of an interesting thought, right? Pets can speak, you know, make sounds, but specific types of pets, so general to specific, once again, can make very unique sounds. And so the example here is that the dog says woof as opposed to hello. Right. So we call these overriding methods, basically. So pet is the superclass. So here's an example of pet, right? So pet is the superclass, and it has inside of it this method called speak. And I want you to look at this keyword that we're adding here to the mix. This is new, right? Called virtual, and it indicates that it may be overridden. So the superclass is set up to allow for this to happen. Right. So in other words, let's think of the scenario like if I create some sort of a pet, like maybe, you know, maybe I'll use the example of a parrot, right? So maybe I write a parrot class, but I don't include a speak method with that, which would be silly, but, you know, so that would only inherit from the superclass. But by setting the keyword virtual inside that method definition inside the superclass, we can now override it from the subclass, right? Remember, it's generic for all pets, but virtual indicates that it can be overridden. So when we're overriding it, so when we do the dog and we're inheriting from pet, when we use the same method name, we now have to include this new keyword override to allow for it to happen. And it's basically telling us, hey, we're overriding the method that comes from the superclass. We're using ours instead of that one. So it's going to woof, not say hello, right? So it is specific for dogs. So from general to specific, once again, the virtual keyword in the superclass, the override keyword in the subclass. So I think that that's pretty helpful. And I'm trying to look here if I have typed up an example of this. And I have, and you know what, I'll go through these examples and then I'll show you my sample code that goes with this. So, all right, so then if we run this code, and we're going to try a little bit of this, by the way, it says C# always chooses the lowest implementation, right, automatically. The subclass class method will run, the superclass will not. So we'll instantiate a dog, we'll call that dog and ask it to speak, and the output will be woof, right? Um, now, just so you don't confuse the terminology, overriding is when we have two methods that have the same name, and in some cases, oh, I'm sorry, overloading is when we have two methods that have the same name but different parameter lists. So if you remember, like, but that would be part of the same class. So we had, for example, remember when we did the add thing? That was a kind of a good example. So in one case, we have an add that accepts a list and another add that accepts integers as an array, right? And depending on what kind of thing you feed into it, that's the one that will trigger. Overriding is a little bit different because it's looking at the subclass superclass relationship. So just to make that clear, right? Um, you know, and we did a little bit of the overloading last week. So we even used two different constructors, if you remember. The one constructor had no arguments, and the other constructor had like two or three arguments. And so if you sent it in with nothing, it would create some default. And if you sent it in with something, it would look at the other constructor and operate. That's overloading. And then overriding is where we're using the localized version because we're allowing it to, and this one is being allowing that one to override it, right? But we need those keywords in place to make that happen. So this is overriding. So I think what might be kind of a fun little thing to do here. So I'm going to just kind of pull from my examples. So we've created basically you know, this rectangle and cube class here. And you know what? I'm going to leave those here. So I'm just going to, I guess I'm going to go with the approach that I did all my examples on my own. And, you know, I created, you know, the cube example. And what I'm going to do with this code now, just to show you, is I'm actually going to create a new function here. And, you know, the function is basically not going to return anything. So we're just going to call it void. And let's just call it, I don't know, first try it out, cube. You know, I can't think of a good name right now, so I apologize. It's not what I called it there, by the way, but I think this might be better. And what I'm going to do is I'm just basically going to take this code that's inside here, just so I can maintain it, and just drop it into this function. And then, what am I missing here? Why is it? Oh, okay. All right. Well, I need to call it, I think is what it is. So let's do first. So it's not auto completing. That's really strange. Just save this. Wants it. Oh, I see what it wants me to declare public or private. That's what it's actually saying. So I'm calling it public. It still doesn't like my name. So what's the problem here? A namespace not directly contain members such as fields, methods, or statements. It's kind of a weird message. And is it offering me a way to fix it? Let's see if it offers a way to fix it. Get on the tool there. It says Alt Enter to show potential fixes. For whatever reason, my engine here is not being very cooperative. Let me do a save again. And what are we missing? There is a thing we're missing. I'm trying to see if you guys can kind of help me out here. I created a function. It's not returning anything, so I'm using the keyword void. Is there anything else I need to include to make this work? Somebody's got to remember this from the previous modules. Nope,
You need to
nope.
call it?
What's that?
You need to call it?
Yeah, well, calling it right. So, let's do that. I'll give it a call, and you can see it's not even pulling up the name, right? So I'm gonna like force type it in here first. Try it out. Cube, I think, is what I called it, right? With a semicolon. All right, now I have two red underlines, and it says it doesn't exist in the current context. Oh, here's why. Duh. Okay, so this is my bad. Right? It's not inside the main program. That's the why. So it can't execute, basically. Right now, I'm calling it. It's still red underlining. Is that okay? Object a reference is required for the non-static field. Okay. So maybe, do I want to change it from public? No, I actually want to change it to static. And we're going to learn about that keyword, by the way. So now it's going to work. Right? So we are working towards learning what that means. Static means it's not changing. Because it's all part of the main program class, what I'm trying to do here, folks, if you guys are wondering, is I'm trying to take my previous example, turn it into a function so I can execute it, right? But I don't want to execute it every time, right? So I'm going to come up with a bunch of different examples here, and I want to do the same type of thing. So what I'm going to do with all my examples from now on is I'll create a function for them to run all the class files. All right, now I'm ready to do my work. But you know what? Maybe I should make sure that this still works okay, right? Does that still work? Yeah, it still works. All right, so we're good. All right, let me go ahead and comment that out again. And let's come down here. So outside the program curlies, and now we're going to create our pets. And I'm trying to find my code here to save a little bit of time. God, this file is way too long. You know, I don't know if you guys like ever have written code like that, but you will, trust me. Man, I've created some program files that, were like tens of thousands of lines long, probably not the greatest idea. It's usually better to separate your code. All right, let's go ahead and create a public class. So we're creating an internal class file here. We're going to call it pet. Curlies. Let's spread those out a little bit. And then inside here, let's create I'm going to zoom in so you guys can see it a little better. And I'm going to create kind of the same kind of thing we did before. We're gonna throw in some properties here just so we have something to work with. Oops, sorry. Copy pasting the. Let's Control Z that. Copy pasting from the wrong screen. So here it is. So I'm going to create a couple of data fields, a name and an age. Right? I guess I could suppress that with the question mark. All right. Now I'm going to create the method that we're going to end up overriding, by the way. And the method here is speak, right? Same one we had in the example, and we're using the same exact thing. Okay. So we're going to say hello. Now, we're going to do something really, really basic here. I guess, I really could have skipped these data fields right now, so we're actually going to use those later on. So if you want, you can comment those out, by the way. But now, since we've already created the really rough basic structure of the pet, right? It's got a couple fields, but it's going to be able to speak. Now we're going to create a separate class file. And this one we'll call dog. Right, so dog will inherit from pet, and then we'll get our curlies in there. And then we're going to declare another method with the same name, and we're allowing for the overrides. Notice the virtual keyword and the override keyword. All right. Now let's go ahead and write some code and get it to do stuff, right? So you guys, this isn't required work for you guys, so I'm gonna kind of like err on the side of caution here and just kind of do a whole lot of copy pasting. The first thing that I'm going to do is I am going to create a static void, and I'm not going to do second try it out because this isn't a try it out. Let's call this the override demo, which is what I called it before. So I'm just going to follow that technique. And then I'm going to write my code for it here and then call it from up above. That's my technique. First thing I'm going to do is I'm going to create a dog. Right. And then, well, if you want, and from the examples, I mean, I already created the data fields for this, by the way. So I'm going to go ahead and throw in an age and a name. I mean, why not, right? We're not going to use them, but I'm still doing it. And then what we want to do also is, okay, well, you know what? If I am going to do that, so here's kind of my thinking on this. Here's what I'm going to do. I'm going to ramp up my example a little bit. So I'm going to go back down to the pet thing again. I'm sorry to jump around so much. But we're eventually going to like want to output these things, and there's a few different ways that we can do this. And actually, I don't want to give away this piece quite yet. So I'm going to hold that thought. I apologize for jumping around so much, but I'm still giving the dog a name and an age. All right. But now if we want the dog to speak, right, we just simply say dog dot speak with parentheses, and which speak will it trigger? That's right. So we saw this in the example. And you know what? Since we're not utilizing these two fields right now, if you want, and I'm just putting it out there, you could comment those out. That would be fun. Let's create the dog. Let's make it speak. And now we're going to call override demo up here. So that's kind of the point of this. We're not commenting here. We're just going to call the override demo. Let's run it. What comes up on screen? Oh, nothing. Why is nothing happening? All right, let's trace it down. So we did something wrong here. We're creating a new dog. So what does that require? Well, there's no constructor function. So you guys noticing that? So is it actually creating the dog is the question. If it's not creating the dog, and then I'm calling this method, should it be returning? Well, it's returning a string. So by calling speak, it's not going to print it. You guys follow my, right? It's just sending the string back, but the string has nowhere to go. Right. So now what we really need to do is we're not going to tell the dog to speak, but we're going to actually console write line. And I'm just going to borrow this. I don't have to type it. Just lazy. Right. And then we're going to put that inside of parentheses. And now we're going to write line the result of that, which returns a string and it will print. See, right? That makes sense? Right. So that makes sense. All right. So now let's try running it and see if it barks. It barked. And this time we have ARF, whatever. Woof, ARF. I think it's really fascinating. If you guys want to study something really bizarre, ask people who speak different languages what sound a dog makes when they bark, or a cat meow. It's really very fascinating how different all the cultures do it. So if somebody asks you what sound does a dog make, and you teach your kids, what sound do you tell them? Yeah, right. Exactly. Kind of an interesting thought. All right. If we want to kind of take this example one step further, the other thing that we could do is we could make a cat, right? Cats are pets. So I could create another uh, public class here called cat, which also inherits from pet. And then how is a cat different, and maybe how a cat is different is that when it speaks, it goes or mew or meow. I think meow is better. Or maybe it hisses. I don't know. We have a young kitten in the house right now, so it's very amusing seeing how it's learning to interact with the other animals we have in the house, because we have a few cats and a dog. Um, and the dog tries to have a standoff with the cat, and the cat, I think they're just smarter than dogs. I think when it comes down to it, dogs are more sociable, but cats are a little bit smarter. She just like hisses at him a little bit, dog backs down, and she just runs right through her legs. The dog can't stop the cat, basically, even when it's a kitten. All right, so now we have a cat object here that we can create. So let's come back up here to the override demo, and let's create a cat. So we'll say cat, and we'll just make it lowercase cat to make it easy. And then we'll do the same approach, cat speak, run it, and it should meow. All right, but let's do also an example of um, one more class file here. This is maybe going a little too far with it, but let's call this a class, and let's call it lizard. Right, lizards aren't known to be very talkative, by the way. That'll also be a pet, and then we'll also have a speak method for that. But the lizard, well, you know what? Let's not have a speak method for the lizard. Let's not have anything in here. That was really my point. The lizard will do whatever it does. Right now it's empty, but we can still create it. So I'm going to save that. Now let's come up and make a lizard. So we'll say lizard, and we'll do lowercase again just to make it easy. And then we'll console write line. Well, it doesn't have a speak method directly built into the class, but there's a super class one. So we can just say, can we say lizard speak? And notice how the IntelliSense is not picking it up. Apparently it doesn't like it. So can we even do that? This is an interesting experiment, isn't it? But I see that I have a flaw in my logic here, because I called the data type and not the actual thing. So it still will work. Kind of an interesting little thing there. It's really easy, especially when you're naming the stuff I'm naming it. So I create the object as a uppercase data type, and then I name it lowercase when I instantiate it, and then I get confused between the two. That's why it's good not to use the same names, by the way. Let's see what this does. Let's run that. And then notice the lizard that doesn't have a built-in speak method is using the super class version, right? So just to kind of, let's pull the console over, right? So lizard, because it doesn't have a speak method, is just pulling it from the super class. Right? Hopefully that helps to clarify that concept a little bit more. Are there any questions on this? Anybody trying it with me, getting it to work? Okay. Not too hard to put it together, but even if you're just watching, it's okay, right? As long as you're latching onto the concept, that's really the more important part here. All right, let's move on in the PowerPoint. We are going to take another break, I think. And you know what? Let's go ahead and do that break now before I get into the next section. So let's do another 5-minute break, and then we'll proceed from there. So I see it as, let's call it 8:57. We'll come back at about 9:02 or 9:03. So I'm pausing the recording, folks. Okay, we are back from our break, and we're going to move on to the next topic. And we're going to look at this thing called toString. which is, kind of an interesting default method that's available to all objects, by the way. So let's talk about that and where it comes from first. So if you're wondering, like we are like instantiating objects now from classes, and we're kind of doing it pretty routinely because it's not really that big of a deal. But if you're wondering, is there a superclass that overrides all objects? The answer is yes, right? So, and that is the object class. So we ultimately, whenever we're creating objects and classes, we are, all of the things that we create are subclasses of the superclass that's at the root of C# called the system.object class. That's where it comes from. And there's a bunch of capabilities that are built into that class. And it says if we don't specify a superclass, object is by default the superclass. And we are inheriting its capabilities regardless where in the tree structure we are, whether we're way up at the top or way at the bottom, we can pull in that capability. So ultimately it says every class is ultimately an object of the object class. Not to confuse the terminology, kind of interesting how they built this. So it says if the object class, if a superclass contains what subclasses have in common, it says what can all classes in the C# language possibly have in common, right? So if we think about like these examples of like insects and animals and recipes and ingredients and whatever, what is it that they can possibly have in common? So one thing that objects do have in common is every object can generate a string output, basically a representation of what it is, because built into it is a method called toString, capital T, capital S, that allows you to take basically the contents of that object and output them as text, right? So we can see what's in there. That's kind of like the thinking. So every object, no matter where in the tree it is, has that method available to it. You just have to call it, right? And that comes from the superclass object way at the top of the tree, no matter how far down you go. So that will always be there, and you call it. An example of how we might use this, so with a toString method, that's automatically called when you print an object. So we've been kind of doing this already, sort of, right? So take a look at this example. We have a customer class somewhere, and we're instantiating a new customer. And apparently we're instantiating Bruce Wayne's zip code and name here. So it's being Gotham City, right? And we create the object, and then we can go right to a write line. And if we write line the whole object, right, without specifying which property, it will display module7.customer because that's how we're building the code. So like, okay, I called mine module7, try it out, or whatever. So it would indicate the whole namespace structure of it, the namespace, and then the object within it. That's the hierarchy. And then if I concatenate it to a string, it still will, print that way. How does this work? Well, it's the toString method. It automatically happens. We don't even have to say it. We don't have to say, hey, customer toString, and then print it out, right? However, okay, so there's a however to this. You can call it directly as well. So if you prefer, and some programmers do, and this is kind of a matter of habit for many of us, is we can create the same object and get basically the same results by including the toString method at the end. The previous version, toString is implied. We're not directly calling it. It just happens because, hey, you're in a write line, you must be wanting toString, is kind of thinking. Here, we're directly calling it on purpose, and it still operates the same way, right? So whether we call it or not, it works. That's kind of the point, right? So one's implied, one's explicit. We're directly stating it. And it says the default behavior toString, it says it's not very useful. I don't know about that. I can be useful. because it's sometimes nice to see what you're contending with. So that's kind of a helpful thing. If you want to see what object you're working with, what namespace it's in, you can just do what we did. But what we can do, and this is kind of interesting, is we can write our own toString method, which overrides the original. Kind of a weird thought, but we can do that, right? And if we do that, following all the correct conventions, of course, with the coding, C# will instead use our version of the toString method rather than the default one, which, according to bullet number 1, is not very useful. And I guess if you think about it, I don't know why this would be useful. All this really kind of indicates is that it exists and what its naming structure is, namespace and object. Right? So maybe that's a good point. Maybe it's not very useful, because maybe really what I want out of that object are the details that come out of the data fields or the methods or whatever. So we have to control that. So it's up to us to kind of create it, and then the engine of C# will kind of allow it to happen. So the first thing that we have to do, by the way, is understand that in the object.cs file, and this is kind of interesting, when we are instantiating objects and classes, what this is really telling us is that object.cs file, wherever it is, that's actually part of our project when we create a project. Right? Whenever we use the class file, that's included somewhere. We're not seeing it, but it's there, right? And then in that CS file, if you could find the toString method, it looks like this. It's public, virtual, which allows overriding. It returns a string, and it's called toString. Now, if we're going to write our own version, then we have to use the correct verbiage here. So once again, we'd call it public, but now the override command, sending back a string, and then we call it toString, and that's in our class file, regardless of where it is in the hierarchy, top to bottom, how many superclasses down you are. It's in the most localized version, right? It says, be careful. We have to make sure that toString is exactly the same way. So you can't like lowercase t or lowercase s or whatever. It's got to be precise. You cannot fudge that, right? At all. So you might create something like this. And I think what would be kind of a helpful little example is to create one of these using maybe our pet class. I think that would be kind of helpful. So if I, for example, took this and added it to our pet class, but I adjusted it for pet, that might be kind of a nice little thing. So let's make a couple of tweaks to our code and try this out. Now, if you guys are kind of curious here, so this return statement is returning a string in the format of a string interpolation. So what we would put inside of a console write line. So the $sign to allow for the string interpolation, and then the the correct format for doing so. Well, let's go back to the code for a sec here. And I'm going to go to the super class of pet, and I'm going to drop in my override from the object class, right? We're overriding the master one, or the super class version. And I'm just going to put in a toString that now is going to utilize the name and the age. If you guys are wondering why I threw those in, that's why, right? That here's a utilization for it. Now, if we're going to do that, when we instantiate our pets, we better start including the name and the age in those instantiations to make sure that we can output it. And then we could call this and try it, right? So let's do that. Let's go ahead and do an override and call this method, but let's set the pet stuff first. So up here where I had commented out the age and the name of the dog, right? And right now we're not too worried about the cat stuff or the lizard stuff. Let's just comment that out. I just want to show that we're okay there. It doesn't like my CSS style commenting here. Oh, there we go. All right. Just took a second for it to kick in. I must have too many tabs and windows open, pushing my machine a little hard when it's kind of slow to respond like that. All right. So you know, the dog speak thing, fine, it's gonna woof and whatever. We'll let it do that still. But when we go to kind of utilizing this, right? So if we're gonna call this, how do we call this? We still would call whatever pet we created, and then we'd call it to string, and then it should output basically the name, age, right? Says, and then it does the speak. So I can actually skip the speak thing. We're gonna, you know, that's gonna be built in somewhere else. So, oops. So can I just now do this? Can I go dog? What method do I call to string, right? And I want you to notice that I'm pausing here on purpose, right? Because the engine inside of Visual Studio is picking this up and showing us very useful information. So I like just arrow down to string, and it says string pet to string. It shows you where it's pulling it from. So even though it's a dog, it's pulling it from the super class that has its own to string, and it's showing us that it's an overload or an override, basically. All right, so let's just go ahead and drop that in. It is a method, so we want to put parens on it. And is this enough to make it output it? Yeah, right, because it is going to return a string. Okay, so let's think about this for a second. It's going to return a string. Do I need to console write line this? If I run this right now, will it put anything on the screen? Okay, the answer to that, by the way, well, let's find out. The answer to that should be no. Okay, so let's go back to the Y on that. It's just returning this. It's waiting to be inserted into a console write line, right? So here, let's go ahead and do that. Let's do a console write line, and we'll do dog to string. And notice how Visual Studio picked that up very intuitively. So this is not the approach you want to use. So we're going to remove that. All right. And let's run it now and see what happens. And will it output anything? Oh, yes. Jack, age 4, says ARF. Isn't that cute? And so there's proof of it working. Now we can take this actually a step or two further. And I'm going to do this right now because I think it's kind of helpful to kind of see that we, at this point, have put this override inside the superclass, overriding the other superclass, right, that sits above it, object that has its own to string. We're overriding that, but we could potentially, and you know, I'm going to see if you guys can follow my logic on this. All right, well, what if I take one of these, or we prove that the dog can bark, but maybe the cat, instead of using the superclass pet override to string, can have its own override method. So here, and I'm just going to drop this code in. So if you guys want to type it in, you can. But this is kind of like the sneak preview of where we're going next with this. Is I can also, because the base class has a to string method, I'm going to use the base method's to string method and override it here because it's a cat, right? So it's going to meow. It's going to give us the name, the age, the meow, because it's a cat. That's what it's going to say on the screen. Kind of, this is kind of a silly example. And I haven't actually lectured on this yet, I guess. So this is, let's call it a preview. So let's go back up here and adjust the cat code and kind of bring that into the mix. So we have our cat is back. We're not going to have it speak like this. So let's just comment that out. And right now we're not too worried about, I guess, the lizard. So let's, lizard. And I guess we can just take that right line. You know what? Let's not comment it out. Let's just alter it. So what would be the correct call here, what am I calling? Do I take the first option here? You should be nodding right now. You should say yes. Okay. ToString like that. And what's kind of interesting about this is this will reach down to cat. Right, so let's just go down here. It'll look here and say, oh, you want to use the super classes toString and then add a little something to it. So we're utilizing the super class and then we're augmenting it, right? So we're doing a double override here is basically what's going on. Right, let's go ahead and run this. And maybe, oh, and we have one problem here though, right? We set a age and a name for the dog, but we forgot all about the cat. The cats are people too, right? So let's say cat, okay, age 5. I'm just going with whatever it's suggesting. And then, well, our new cat's name is Mojo. So let's go with the real cat name there. Let's go ahead and run this. All right, you'll notice. So the dog one uses its own internal override. The cat one uses the super classes override and then augments or adds to it because it's a cat. And actually, Mojo's age is under single digits right now still, right? Because he's only a few months old. But clever little, cute little guy for sure. All right. So any questions on how that operates? Is that fairly clear? Right. All right. Let's go back to the slides and kind of finish off this section here then. So now when you look at the next example, so we showed how to do the override. And there is a shortcut way to do this too, by the way. So if you wanted to use the object initializer approach, that's where you do the equal sign bracket, you know, the greater than sign. Instead of going through, you know, the curly bracket approach, you can omit the curly brackets and directly go to the output. And most coders would write this all on one line, for example. So with the cat one, if we wanted to convert the cat one to that format, it would basically be as simple as kind of removing the curly brackets. I got to make sure you get rid of both of those here. So let's do that. And then here, I would just simply use this syntax. So I don't need a return. The equal bracket is basically saying return. So this is an alternate approach. I don't know if you guys remember this from last week when we did the classes. They had a similar thing there. I just want to make sure that we're demonstrating it. And just to prove, right, it still works. We run it. Yeah, actually have to hit the button now. There you go. So it still works, right? I will tell you that what I've seen in a lot of modern programming is if it's a really simple return statement like this, a lot of programmers just go to this thing, you know, because it's on one line, right? And it still works. It's basically the same code, right? They're just replacing curly brackets with this silly little symbol. And so the encouragement would be for you guys as modern programmers to go with that approach. Let's go back over to the slideshow. All right, so that's an example of that. Okay, so now they're saying, okay, now our customer is printing nicely. So they go to the original. This is the one that comes from the object class. No toString is specified, right? And then we look at the, you know, the try it out that comes with this. And I mean, maybe we've already completed all of this. Oh no, this is a completely separate exercise. That's right, forgot. All right, so here we have another try it out. And what I'd like to do is try to do this try it out. I'm looking at the time here. We'll do this and then we're going to call it a night because we're at a really logical stopping point in terms of content. You know, a little more than halfway through and some coding examples, you know, thrown into the mix. All right, so here's our grand directive and it says, create a class named television with the following properties. A Boolean for whether it's on or off, a double for the current channel, a string for the manufacturer, create a toString method that returns a string like this, so we'll recreate that. And then we'll have a driver class where we will create and write some television objects to test the method. Right? Kind of what we just did with the pets, but now we're gonna kind of build it from scratch again. I'm still gonna use the same code file, folks. I think it's been working okay. What I am gonna do is with all these classes I've created, I'm gonna push them down out of the way because now we're gonna create more stuff up here. So we have our, our original cube thing, and then we have our override demo. And then inside here, let's create another function. Doesn't return anything, it just executes. And this is going to be, I don't know, television. Yeah, that sounds good. Just call it television. And let's put in some curlies. And now we're ready to write some code. Up here in the main method where we're running everything, I'm going to comment out the override demo since we're done with that for now, right? And the thinking here is you can trigger any of these by just uncommenting them, right? If you want to see how they operate. I'm going to go ahead and preemptively put in a function call to that. So let's just call television, just so that when we hit run, it actually works, right? So, because otherwise you forget. If you don't call it, it doesn't work, right? So that's the one thing that's always kind of critical. We will need to create some classes here. So I'm going over here to my pre-built code, and I'm going to create outside of that area there, I'm going to create a new public class, and let's call it television. And then let's create the data fields that we were asked to create. So we were asked to do a Boolean to see if it's on with a getter or setter. We're also going to create the current channel. That's supposed to be a double. I'm not sure why I think of it as an integer, but whatever. Also with a getter and setter. And then I did something kind of weird here, and I'm not sure we necessarily have to do it this way, but this is what I did. So let me just paste that in. So I created a string for the manufacturer that we can only get, right? Because when we construct the TV, we're going to set the manufacturer, like Samsung or Sony or something like that. And then once it's set, you can't change it, right? Because we can turn the thing on and off, and we can change the channel, but we can't change the brand once it's built. You get the thinking here, right? Right. I can't all of a sudden turn my Samsung into LG. That's not going to happen. At the factory, maybe, right? They might be built in the same factory, by the way. Kind of interesting, because the other school I teach for, interestingly, is basically in the zone of Foxconn. And you guys know the whole Foxconn story and scenario. We have, Gateway Technical College, which is Racine, Kenosha, and Walworth County. We have 3 major campuses, one in each county. And then with all the different facilities I think we have like 9 or 10 different campus locations, including our engineering center, which is literally like a half-mile down the road, or up the road actually, from where Foxconn is building all of its stuff. And so we kind of get to watch what they're doing. We get invited over there all the time. And what a lot of people don't know about Foxconn is the world's largest contract manufacturer of consumer electronics. It's estimated that about 75% of all the gadgets that we play with are made by Foxconn. Okay, granted, not in Racine or Kenosha County, right? That was kind of the hope. But over in Taiwan and China and Japan, where they have like really huge facilities, they are a Taiwanese company, by the way. But they make a huge amount of electronics. It is mind blowing. Right now, if you guys are curious, the one project that they're working on, to my understanding, is that they're building servers for Google at the rate of 1,000 servers per day, because that's how many Google is adding to their server farms to keep up with the growth of their cloud infrastructure. Now, when I think about that, I'm like, oh my God, that's insane. Because I think about the capability of one server, and which it's like taking a computer system, multiplying it by like 1,000 or something, and then we're adding 1,000 of those a day. That's how fast Google's cloud is growing. That's insane, right? Kind of weird stuff to think about. All right, sorry for the diversion, but I'm also gonna basically create a constructor function here, and I'm just gonna paste this in. I don't want to take the time to type it. And so when we call the constructor, we're going to feed in the current channel. The manufacturer will be fed in, but when we create the television, we're not going to create it with the power on, right? We're going to create it and the power's off. So we're not setting the is on field. We're setting it to false. We're not even feeding it in. So when we construct the television, we set it to a channel, maybe channel 1, and then or whatever channel we want to put it on, and we attribute a manufacturer to it. Now we will, basically create capabilities later where we can trigger that property to on and off because it is public, so we can trigger it. So that was kind of my thinking when I built this. All right, so now that we've created the TV class, now we have to do the next step. And what is our directive here? All right. So we created all this stuff. Now we want to create a toString method that returns a string like the Sony television is tuned to channel 4.1. It is currently on. Okay. So let's do that task here. So I'm going to begin by just saying public. We do have to do an override, and then I'm going to output a string, and we're going to call it toString. And then you see what it's trying to do automatically. This is Visual Studio doing this. I didn't type a darn thing. It just dropped it in. It says, oh, why don't you just return the one from the object class is what it's telling me, right? Because what's the super class, the television? The object class. Okay, that's not what I want to do. I'll leave the semicolon there. But the rest of it, I'm going to kind of mess with a little bit. All right. So let's kind of write a little bit of code here. And I did this a couple different ways. So I'm going to show you first my one technique. I'm going to paste this in, by the way, as in the form of a comment, because when I experimented with this, what I did, oops, sorry, Control Z that. So what I first did was this. I'm just leaving it as a comment for now, but I'm not going to use it. Right? I just want to show you how my brain was working. So first I created a variable called output, and I pre-populated it with some stuff. Manufacturer of television. Okay, so the Samsung television is tuned to channel 5. It is, whatever. And then I have an if statement. If it's on, output on, we're going to add that to the output string. Otherwise, output off. And then we'll also do an output. And you guys remember this format here? You guys remember what we call this? It's a ternary operator. So this is the alternate way of writing kind of that same if statement. And my whole point of like doing this example was, it's like, okay, well, we don't know if it's on or off, so we can check if it's on or off, and then we can display whether it's on or off, right? So I did all this experimentation, but then I decided, you know what, there's an easier way to do this, because of the ternary if statement. And so what I did instead was this, right? So I just did a straight string interpolation, right? And got all of it into the same statement. And I want you to look really carefully here as part of the string interpolation inside of parentheses, right? It basically is doing that same operation. So it's checking is on, is which is a true or false, right? So I don't have to write a complex statement. That's a Boolean. So it is on, and we originally will have it set to false. And then if it's on, display on. If it's off, display off. All right, so let's kind of mess with this a little bit now. So we've created the class structure, we've created the constructor, we've created the whole thing, and then the method to string to override the original. I am going to blow this code away. Screenshotters can capture it if they want, but I like my much more efficient code here, frankly, right? And you see how much like less coding that is, but it's basically doing exactly the same task. And I think that's really kind of neat and clever. We're also not storing it in a variable. So ultimately, this becomes more efficient memory-wise. The other approach, and let me just Control Z this here. The other approach, because we were storing it in a variable, we are occupying memory space, right? We're storing it, and we're taking away RAM from other programs that might need it, as opposed to just brute force returning the value. All right, so let's go ahead and delete that again. We'll just blow that away. Okay, now let's go back up here and instantiate this. And I'm looking at my instantiation code, if I can find it here on my sample file. Just bear with me. Next time I'll make a file that's much shorter. Boy, that file, if you guys could see this file, it is very, very long. And I'm scrolling just to find the stuff that I want to try to do. Okay, so here's my sample code. So the first thing I'm going to do is I'm going to create a television, and I guess I'm going to set it to channel 4.1. All right, so now I'm remembering why I set it to a double, right? So like if you think of like digital TV sets, right? And so like if you do on-air broadcasts, right? All the traditional TV stations, like 2, 4, 6, whatever, they were now have digital broadcast too. So channel 4 has channel 4.1 and 4.2 and 4. I don't know if any of you watch broadcast television at all. For me, pretty much only when the Packers are on do I watch broadcast television. That's like the one exclusive. Right, and it's like kind of interestingly, if you guys cable TV is largely most of the reason why people keep their subscriptions to cable TV is for sports, right? Because everything else you can pretty much stream when you think about it. All right, so we are creating a television here, and then let's just go ahead and do a simple console write line to just output TV using the object superclass toString method. So it's going to give us the namespace and the object name and all that, right? Then we want to actually turn the TV on. And then, you know what? I don't like that channel. I'm going to change it to channel 5.1. Not sure what's on there, but something must be on there. And then we're going to console write line TV. Now, here's the part that might perplex you a little bit as you look at this. You guys will notice that I don't have a toString method here. Now, remember that we can trigger the toString method two ways. One is implied, and one is explicit. So I can either call it or not call it, and it still operates, because when I do a write line, it has to convert it to a string to output it. That's really the thinking. Now, the question is, which toString method is it actually going to output? Is it going to output the superclass from object or the one that we just added? Right? And the answer really should be the one that we just added should override the object superclass. So even though I'm not saying toString here, it should operate. All right, so let's make sure we called it. Okay, we did call it. Very good. And let's run it and let's see if it works. All right. So notice, and I'll go back down to the code that's steering it here. So we create it. we output it. It's tuned to channel 4.1 and it is off. And it's a Sony TV. Then we turn it on, change the channel, we output it again, and now it's Sony TV is on 5.1 and it is on. Okay, so now we're showing that our override method, even though we didn't say .toString with parentheses, is still operating. Okay, let's go back to that slide for just a moment. Okay, so it says create some objects and test it. Well, we created one. I think I'm okay with that. But if you wanted, you could play with it a little bit. So like one thing that you could do, if you're thinking about it, is you could basically just copy all this code. It will throw an error when I do the paste. And you could just call it, TV2, and then, change all these to twos. Oops, not 22, but 2. Right. But then you could, the point of this is if you want to do the toString method, you can call that 2. And then just to prove that it does work. That's kind of my grand point of this. So here we are. Let's go ahead and run it one more time and prove that that also works within UTV. Now, I probably should have been more clever, really, and this one should have been like, Samsung, and that one's starting out on channel 1001.5 or something, weird like that. And then, we could just put basically different values in here to make sure that they're actually working. But then we can prove that it is. All right. So folks, that's the example. I am going to stop this recording here. So this recording ends here, and we will basically resume with the rest of the slideshow. And I think that maybe I'll record that in. So we finished up through slide 46. When we come back next time, we'll look at the static concept and the meaning. And we'll do that on Thursday. All right. So this recording ends here.